everyone, welcome back to my channel. So this is Statistics Week 1, Part 2. In the previous video, we discussed about the basics of statistics and data along with their broad categories. In this video, we are going to cover scales of measurement. So let us start. Scales of measurement is a classification that describes the nature of value stored in a variable. As we discussed in the previous video about what is a variable, so when we define the nature of the value that can be stored into the variable, that is according to a classification known as scales of measurement. We will try to understand this in detail further. So we are having broadly four main categories of the scales of measurement. That is four types of the scales of measurement. First is nominal, then ordinal, interval, and ratio. I have marked nominal and ordinal with a separate color just to clarify that nominal and ordinal, both of these belong to the categorical variable. That is, that these classifications can be only done to the categorical variables, and the two, interval and ratio, they can only be applied to numerical variables. We also discussed about the difference between a categorical variable and a numerical variable in the previous video. You can check it out. Now, first let's discuss. First is nominal. Qualitative data property, that is, the nominal scale of measurement is having a qualitative data property. It is applicable for only categorical variable, as I discussed earlier. The data under this category does not implies any order. That is, when you will have a nominal variable, that will not have any kind of order or ranking. We'll see in the examples. Example gender. For example, we have male and female. So both of these are the categorical variables, and also they do not have any order between them. You cannot tell that male is superior or female is superior. Similarly, we have eye color. You can have black, brown, blue, etc. And there's no order in that. Similarly, our names of countries, our names of states, etc. So these are the most basic scale of measurement, where you have only thing you need to keep in mind is that they are applicable for only categorical variable, and second, that they do not have any kind of order. Next is ordinal. The ordinal scale of measurement is again having qualitative data property. It is applicable for categorical variable, and the only difference between the nominal and the ordinal, as I marked with the blue color, is that in nominal we do not have an order, but in ordinal we have a specific order or a ranking. That is, the data under this category implies a specific order or ranking. Example, t-shirt sizes. For example, I say that I have small, medium, and large. I'll write them as full words, but just for the sake of keeping them short, I'm writing S, M, and L to denote small, medium, and large. So when I talk about t-shirt sizes, although it is also a qualitative property, it is a categorical variable because only two things we can classify. One is a categorical, which is basically like containing alphabets, words, letters, etc. And the second one is a numerical variable. So it is a collection of words, so it's a categorical variable. And the key thing to keep in mind is the one which makes the major difference between nominal and ordinal, that is the ranking portion. So here you can rank them in a certain way. That is, that small is there, and then this. Like small is lesser than medium, medium is lesser than large. Or you can have it either way. Like that. In any way, but you can define an order. Similarly, in the rating of an app, you can have a 5 rating, a 4 rating, 3, and similarly. Here also you should keep in mind that although 5, 4, 3 might seem you as numbers and you can get confused them as numerical variables, but eventually this is not the case because 5 in the rating system, 5 is usually marked as like excellent, 4 is marked as very good, third is marked as good. Then similarly you go down, then 2 is average, 1 is bad. So these are not numerical variables because the one thing that you can do to check always whether the variable is numerical or not, that you can perform arithmetic operations on that or not. So similarly, you have rating over here, like let us say we have taken a set of 10 people and we have told them to rate an app. So all of them might be giving 5, 3, 2 rating, etc. So that can be classified as just the categorical. Like 5 is excellent, 4 is good. So that is not a numerical variable in any sense. Then we have grades. Like in school, you get grades like A, B, C, D. So that is not just A, B, C, D does not have an individual quantity, individual identity, although they are categorical, but you have like A is a good one, B is not a good one, C is a very bad one, like that. So you get the point that they have a specific order or a property or a ranking. Next, we have the absolute zero property. This is a very important property that will help us define the major difference between the next two scales of measurement, that is interval and ratio. We will try to understand this. So it says, this property implies to all those categories where meaning of zero is absence of thing. Now, what do I mean by this? That meaning of zero means absence of thing is the actual meaning of zero. For example, in case of number of pens, 0 pens means no pen. That is, it is absence of pens. So when you are having absolute zero property is very simple. It just says that so as we were discussing example, in case of number of pens, 0 pens means no pen, that is absence of pen. So absolute zero property is as simple as the most common thing we know about what is zero. Zero means nothing. But now in this statistics, we'll get to know that there is a property known as absolute zero property. Not all things obey it, some also offend it. We will understand how it works. First of all, let us go to the next example. Whereas in some situations, zero does not means as usual. That means in all cases, zero does not means absence of a thing. For example, zero pH does not means absence of pH. So whenever any solution you have and you say it is having 0 pH, you cannot say it does not have a pH. You will also, you will be having a value specified as what is a 0 pH, whether it's basic or acidic. Similarly, when you talk about in terms of temperature, that is 0 degrees Celsius, it does not means absence of temperature. There is a temperature present over there. 0 degree is a temperature. It's not that there is no temperatures over there. So here is when we say that there is absence of absolute zero property, example pH temperature. So you need to understand what is absolute zero property, where you have the basic meaning of zero as zero meaning absence of a thing. And there are some categories which do not obey this, where we say that they are having an absence of absolute zero, example in the case of pH and temperature. So now with a basic understanding of the absolute zero property, let us try to understand our next two scales of measurement, that is interval and ratio. First, interval. So it is having a quantitative data property applicable for only numerical variables that can be added, subtracted, but division and multiplication hold no significance here due to absence of absolute zero property. So here our information will become significant that in the interval scale of measurement, you will not have the absolute zero property. One more thing to keep in mind here is that values under this category can have negative values too. And the data here will have a specific order. Obviously, it's a numerical variable, so it will be having a specific order. Now, example at temperature in Celsius. We discussed earlier that temperature in Celsius, when we talk about 0 degrees Celsius, that does not means absence of temperature. So that is absence of absolute zero property, and that comes under interval. Similarly, we discussed for pH. And similar is the thing with the time of day and the IQ score. Like 0 IQ score, you cannot have, the person is not having IQ. So that happens in the interval scale. Next, we have ratio scale of measurement, which is again having a quantitative data type applicable for only numerical variable. But again, we have a difference between interval and ratio, although both of them belong to the numerical variable category. That in interval, we were only performing addition and subtraction. Division and multiplication were having no significance. But here, all arithmetic operations are possible, whether it's addition, subtraction, multiplication, or division. Why? Because due to the presence of absolute zero property. So we see here that absolute zero property, it has a very important role. So it decides the basic difference. Again, in the ratio, we have values under these category is always positive. Again, I have marked the difference between interval and ratio both in blue color so that you can easily identify them. And then the data will have a specific order because it's a numerical data. And its example include height, money, age. So you can see that height, money, age, these are the numbers which can only be positive. They cannot be negative in any sense. And also, you can have any kind of arithmetic operations into that. For example, you are having a class of 30 students and you collected the height of each student. And you can have the minimum height and the maximum height. You may be able to wanting to subtract the maximum from the minimum to get the range of height of the people in the class. And similarly, you can say that one person's height is double the another or something like that. That means all kind of arithmetic operations are valid in the ratio scale of measurement. Now let's just quickly revise what we learned today. So we started with the scales of measurement, that it is a classification based on the nature of value stored in the variable. Then we discussed its four basic types that are nominal, ordinal, interval, and ratio. Then nominal and ordinal both belong to the categorical variable category, and interval and ratio both belong to the numerical variable category. Then we discussed each one of them in detail. First, numerical, nominal, that it is applicable for only categorical variables. It's of qualitative data property, and then that there is no order in the nominal variable. Ordinal, it is again having a qualitative data property applicable for categorical variables, but here you have a specific order or a ranking. Then we discussed a very important property, the absolute zero property, which just means that the meaning of zero is absence of thing. When you are not having this property in any of the categories, example pH or temperature, then you say that there is an absence of absolute zero property, and that creates a lot of difference. Why? Because we discussed that difference in our next two scales of measurement, that was interval and ratio. In interval, we are having quantitative data property, which is applicable for numerical variables that can be only added and subtracted. Here, division and multiplication are having no significance due to lack of the absolute zero property, and value under this category can also be negative. Alongside zero and positive, they can be negative. And then we discussed ratio. That again belongs to the quantitative data property. It is applicable for numerical variables, but where all arithmetic operations like addition, subtraction, multiplication, division, they are possible because there is presence of absolute zero property, and value under these categories are always positive. They can be zero, they can be positive, but they can never be negative. So hope you understood what we discussed today. Don't forget to check the first part of week 1. And if you found this video helpful, do hit the like button, subscribe to the channel, and comment down your queries and suggestions. Thank you.